everyone! Today, we're diving into a fundamental topic in assembly language 8086, accessing and using 2D arrays. This is super useful for organizing data like matrices, game boards, or even simple image representations. We'll break down how these arrays work in memory and how you can manipulate them with your assembly code. First, let's define what a 2D array is. Think of it as an array of arrays, or a grid with rows and columns. Instead of a single line of numbers, you have a table. In 8086 assembly, memory is linear, so we store these 2D structures in a flat, one-dimensional way. The most common method is row major order. This means all elements of the first row come first, then all elements of the second row, and so on. For example, a 3 by 3 array would store element 0, 0, then 0, 1, then 0, 2, followed by 1, 0, 1, 1, 1, 2, and finally, 2, 0, 2, 1, 2, 2. Now, let's see how to define a 2D array in your assembly code. You can use directives like db4 bytes or dw4 words. For a 3 by 3 array of bytes, you might write my matrix db1, 2, 3, 4, 5, 6, 7, 8, 9. It's also good practice to define constants for the number of rows and columns, like num_rows equ3 and num_cols equ3. This makes your code much clearer and easier to modify. Accessing a specific element is the core challenge. We need to calculate its memory address. The general formula for an element at row index, col index, in a row major array is address equals base address plus row index num_cols plus col index element size. Let's say we want to access my matrix 1, 2, which is the value 6 in our example. Assuming each element is 1 byte, element size equals 1, and num_cols is 3. The offset would be 1 3 plus 2, 1 equals 5. So, the element is at base address plus 5. In assembly, you'd typically load the base address of my matrix into a register like bx. Then, you'd calculate the offset, perhaps using mul and add instructions, and add it to bx. Finally, mov al, bx, would fetch the value into the al register. For example, mov bx, offset my matrix, mov ax, 1, row index, mov cx, 3, num_cols, mul cx, add ax, 2, col index, mov bx, ax, add bx, offset my matrix, mov al, bx. Finally, let's talk about iterating through a 2D array. This usually involves nested loops. The outer loop controls the row index, and the inner loop controls the col index. Inside the inner loop, you would calculate the address of the current element using the formula we just discussed. Then you can process that element. After the inner loop finishes for one row, the outer loop moves to the next row, and the process repeats. This allows you to visit every single element systematically. And that's a quick overview of 2D arrays in 8086 assembly. I hope this explanation was clear and helpful for your projects. Thank you so much for watching. If you found this video useful, please give it a big thumbs up, leave a comment with your thoughts or any questions, and share it with anyone else who might benefit. Don't forget to subscribe and hit that notification bell if you want to support the channel and stay updated with more assembly language tutorials. See you next time.